Welcome to another episode of Podcast Name. Today we're diving into a fascinating topic that combines advanced programming with high-performance computing. We're talking about Kokkos, a powerful library designed to make C++ applications performance portable across different hardware architectures. So grab your headphones and settle in as we explore the ins and outs of Kokkos. All right, so let's kick things off. It's in the world of high-performance computing, or HPC as the cool kids say, developers are often faced with a bit of a conundrum. How do you write efficient code that can run smoothly on a variety of systems? This is where Kokkos really comes into play. Now, Kokkos provides a programming model that allows you to write applications that can utilize different execution models. Imagine you have a powerful computer with multiple types of processors and memory hierarchies. Kokkos abstracts away some of that complexity, enabling developers to focus on their algorithms without worrying too much about the underlying hardware. It supports various backends, including CUDA, OpenMP, and even C++ threads. Pretty neat, right? So, how does one even begin to learn about Kokkos? Well, there's a treasure trove of resources available. You can start with Kokkos lectures, which blend lecture videos with hands-on exercises covering all the essentials. There's also a comprehensive programming guide that breaks down the programming model and key building blocks, kind of like the essential toolkit for getting started. You might be wondering, what are these building blocks? Well, they include things like views and parallel dispatch, which might sound intricate, but I promise they're foundational for working with data in Kokkos. Think of views as versatile containers for data. They organize data in a way that's both accessible and efficient. And of course, if you want to dive deeper, there are plenty of use cases and examples available that show how Kokkos interacts with other systems, like MPI or even Fortran. So it's not just isolated to C++, it embraces a wider ecosystem. Now let's talk logistics. If you want to get your hands dirty with Kokkos, you can easily download the latest release from GitHub. The current version, as of the last update, is 4.4.01. There's even a straightforward command to download it directly, whether you prefer curl or wget. And if you're a SPAC user, you can install it that way too. But before you jump into installation, keep in mind that you'll need a C++ compiler that supports C++ 17 or later. It's like making sure the tools in your toolbox are up to date before beginning a project. If you run into any bumps along the way, don't fret. The Kokkos community is there to support you. You can find help on Slack or even open an issue on GitHub. That's one thing I truly appreciate about tech communities. There's always a helping hand available when you need it. And for those wondering about contributing to Kokkos, there's a straightforward guide that details how you can pitch in. It's always exciting to be part of an open source project, right? It feels good to know that your contributions can help enhance tools that many developers rely on. As we wrap up today's exploration of Kokkos, I want to leave you with a thought-provoking question. How do you think advancements like Kokkos will shape the future of programming in HPC? With technology continuing to grow and evolve, what might the next generation of performance portability look like? Thanks for joining us in this episode. I hope you've gained some valuable insights into Kokkos and the world of high-performance computing. Don't forget to check out the resources we discussed, and maybe even start experimenting with Kokkos yourself. Until next time, keep curious and keep coding.